Hello, everybody. Okay, so today we're going to talk about measurement in physics. So this is really some background information. We've already talked about some of this when we went over your summer work, but just to make sure that everybody's on the same page, I'm going to go ahead and give you these notes for you to keep as well. Okay, so in physics we use the SI system for measurement, or the SI system for units. SI is the System International, or the International System, and there's three fundamental SI units. So we measure length in the meter, we measure mass in the kilogram, we measure time in seconds. Now, you're going to see lots of quantities that are combinations of these. And you're also going to see some that are fundamental units on their own that are not listed. But for the most part, for what we deal with in here, these three things are what's going to make up the units that we're going to use later on. So just to give you an example, speed is meters per second. So it's made up of a fundamental unit of length and a fundamental unit of time. Now we can add prefixes to these units in order to make the numbers either larger or smaller. So for instance, a kilometer is actually going to be 1,000 meters, right? So instead of having to write the number 1,000, we could just write kilo, and we know that there's 1,000 of those there. Here's some of the most commonly used prefixes. I'm not going to go over these in a whole lot of detail just because this was part of your summer homework to look this stuff up. Notice that, mega and kilo things are getting larger. This is a capital K, capital M for the prefix abbreviation. Centi, milli, micro, and nano, things are getting smaller. We have these negative exponents here, so times 10 to the negative 2, that means it's 1/100th of something. Times 10 to the negative 3, 1,000th of something. 10 to the negative 6, 1,000,000th of something. And this is centi, milli. Micro gets the Greek letter mu, so that's a little bit different. And nano is 1/100000th of something. Okay, so if a capacitor is labeled at 2.5 microfarads, how would it be labeled in just farads? Now, we're not going to deal with capacitors in this class. This is really just to look at the unit, right? So if I had this prefix micro here, well, from the previous screen, I know that micro means times 10 to the negative 6. So all I'm going to do is I'm going to take out the micro, and I'm going to replace it with times 10 to the negative 6. The radio station XL 106.7 transmits at a frequency of 106.7 times 10 to the 6 hertz. How would that be written in megahertz? Well, let me come back here again. So mega up here means times 10 to the 6. So I'm going to do the same thing I did above, but just in reverse, right? So I've got a 10 to the negative 6. I know mega means 10 to the 6. So I'm just going to replace that and put mega instead, right? So this is 106.7 megahertz. Okay, a little bit of dimensional analysis, right? So dimensional analysis is a way for us to cancel out units. Hello. Okay, so dimensional analysis allows us to convert units, right? The way we convert units is by canceling them out using two things that are equal. So if I know that 60 seconds is the same thing as a minute, I can use that as a fraction to make a conversion factor. And now what goes in the numerator, what goes in the denominator just depends on what I start with. So let's say we want to convert 65 miles per hour to feet per second or to meters per second. Well, let's start with 65 miles per hour. So I always need to write my number and then I have my two units I'm given, right? So miles goes on top. Per is a key word that means divide. So I've got miles per hour. Now first, I know that 1 hour is the same thing as 60 minutes, and I know 1 minute is the same thing as 60 seconds. So I set these up in a way where I started with hours on bottom, I need to put hours on top so that those cancel. Then I had minutes on bottom, I need minutes on top so that those cancel. If I stopped here, I would get miles per second. But that's not what I wanted, right? I wanted to get to feet per second. Well, I know that 1 mile is the same thing as 5,280 feet. Okay, I needed the 1 mile on bottom here because I had miles on top to start with. Those two things need to cancel. Now if I stop with my conversion, now I have feet per second. So what do? Well, I multiply across the top. So I have 65 to start with, times 1 times 1 times 5,280. That goes on top. On bottom, right, it was 65 miles per 1 hour. So I have 1 on bottom times 60 times 60 times 1. 60, 60, and 1. Multiply the numbers across the top, multiply the numbers across the bottom, divide the two at the end, and I get 95 feet per second. Well, now let's convert that to meters per second. So I have 95 feet per second. I know that there are 3.281 feet in 1 meter. In these conversion factors, you can always look them up, right? You could Google how many feet are in a meter. and then figure that out. So I've got 3.281 feet in 1 meter. So feet cancel, multiply across the top, 95 times 1, divide by the bottom, 1 times 3.281, and I get 29 meters per second. Your trigonometric functions, so we need to know these. Basically, in physics, we're going to use a lot of right triangles, so we can always use Pythagorean theorem. Pythagorean theorem is good if we know two sides and we want to figure out what the third one is. If we have an angle involved, right, maybe we want to figure out what the angle is, or maybe we only have one side and we know the angle, and we want to solve for another side. Then we're going to use a trigonometric function, right? This is your good old SOHCAHTOA. 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 Okay? So there are three things in each one of these equations, right? I've got the angle over here, I have the opposite side, and I have the hypotenuse. If I know two of these, I can solve for the third. And so it just depends on what you're being given in the problem, right? Identify which side of the triangle you're given, which angle you're given, and which side of the triangle you're looking for. And then pick which trigonometric function you need to go along with it. Now, if you need to figure out what the angle is, right, this is where this -1, this inverse thing comes from. Let's say we know the opposite and the adjacent sides. I know these two sides. And I want to figure out the angle. Well, that means I need the tangent function because I know the opposite and the adjacent, and I'm looking for theta. But I need to get theta by itself, and I can't just divide by tan, right? Tan is not a thing, right? Tangent is a function, and tangent is a function of theta. So I need to undo that function. Think about like undoing a square. If I have x squared, I can't just divide by 2 and get rid of it. It doesn't work that way. I have to square root it. I have to do some kind of other function to undo the first function. In this case, the function that undoes it is the tangent inverse. So tangent inverse of tangent of theta just leaves me theta. Those two things cancel each other out. But whatever I do to one side, I have to do to the other side. So on the other side, I will do a tangent inverse of the opposite side divided by the adjacent. Tangent inverse, opposite over adjacent. Let's look at an example here. So I have a person attempts to measure the height of a building by walking at a distance of 46 meters. From its base and shining a flashlight beam toward the top. He finds that the beam is elevated at an angle of 39 degrees. So there's my angle, 39 degrees. With respect to the horizontal, the beam just strikes the top of the building. Find the height of the building and find the distance the flashlight beam has to travel. So what do I know? Well, I know the angle here. I know this is 39 degrees. And then I know this side of the triangle, right? I have 46 meters. Well, this is going to be the adjacent side, right? The adjacent side is the side of the triangle that touches the angle, but is not the hypotenuse. Okay, so 46 meters is going to be the adjacent side. Well, let's look at this. I'm also looking for height, right? Well, what is the height? The height is the opposite side. So I'm interested in the opposite, the adjacent, and theta. That's going to be tangent, right? TOA, SOHCAHTOA. Opposite and adjacent, and I have theta there. So I know that tangent of the angle, 39 degrees, equals the opposite side, which is the height, divided by the adjacent, which is 46. Well, how do I solve for the height? Well, height's being divided by 46 meters, so I need to multiply both sides by 46 meters. When I multiply the right-hand side by 46, they cancel, and I'm left with just the height. That's what I have here. Well, whatever I do to one side, I do to the other, so my tangent at 39 degrees needs to get multiplied by 46 meters. So I end up with 37.3 meters. Okay, so that's how I get the height. What about the distance the beam travels? Well, the distance the beam travels is here, so it travels right along that line. So this is going to be the hypotenuse of my triangle. At this point, now I know two sides of the triangle. I can use Pythagorean theorem to solve for the third. Right, so Pythagorean theorem, I get 59.2 meters. Let's say a truck driver moves up a highway mountain. The elevation markers at the beginning and ending points of the trip show that he has risen vertically by 0.53 kilometers. And the mileage indicator on the truck shows that he has traveled a total distance of 3 kilometers during the ascent. Find the angle of the hill. Okay, so his elevation or his height changes by 0.53 kilometers. The distance that the truck or the van travels is 3 kilometers. That's the hypotenuse here. And so the angle theta is what I'm looking for. Well, this is the opposite side, right? The opposite side is opposite the angle I'm interested in. It does not touch that angle. And then this 3 kilometers is the hypotenuse because it is opposite of the 90 degree. Okay, so knowing the opposite side and the hypotenuse, I'm going to wind up using the sine function, right? So sine of theta is the opposite over the hypotenuse, right? SOH, SOHCAHTOA. But I want to find the angle, right? So I actually need to use the inverse of the sine. So sine of theta is the opposite side, 0.53 divided by the hypotenuse, which is 3. That gives me 0.177. And then theta is going to want to be the sine inverse of that number, 10.2 degrees. So just a bit of algebra review real quick. An equation says that two things are equal, and it will always have an equal sign. A term is either a single number or a variable, or numbers and variables multiplied or divided together. The key thing here is terms are always separated by plus or minus signs. So 3x squared is considered one single term. An expression is a group of terms. So an expression does not have to have an equal sign, but it will have multiple terms that are separated by addition and subtraction. So 2x cubed plus 5, well, 2x to the third is a term, 5 is a separate term, and so that's two terms in one expression. Here, 9x squared plus 5x plus 2 is three terms. 1, 2, 3. Like terms are when variables and their exponents are the same. Like terms can be combined through addition and subtraction. So 3x squared and 2x squared both have x squareds to them. They are like terms. I can add them together and get 5x squared. So to find the reciprocal of something, basically we just exchange the numerator and the denominator. So we flip those two things, right? Whatever's on bottom goes on top, whatever's on top goes on bottom. If I start with the number 2, the reciprocal is 1/2. The reason is that 2 is the same thing as 2 over 1. So if I have 2 divided by 1, I flip those things, I get 1/2. The reciprocal of x is 1 over x, because again, x is the same thing as x over 1. I just flip those two things. 1 over x, the reciprocal is x. Again, flip them, and so when I flip them, I get x divided by 1. X divided by 1 is just x. Now, let's look at this number 2 again, right? So we know that 2 has a reciprocal of 1/2. Well, I could also write that as 2 raised to the negative 1 power. The laws of exponents allow me to just change the exponent to a positive or negative depending on if it's on top or if it's on bottom. As I flip those, I just change the signs on them. Same thing with x, right? So x, the reciprocal is 1 over x. Well, 1 over x is the same thing as x to the negative 1. Delta operator means the change in something. To calculate the change in something means you take the final amount and you subtract the initial amount. If I start off with $100 in my bank account and I end up with $500 in my bank account after payday, I had a change in my bank account of $400, right? The final was 500 minus the initial of 100. That gives me my change in. One important thing about the delta operator, the Greek letter delta, this little triangle, is not its own variable. So you can't separate that. You would never divide just by delta. Right, it's an operator. Exponents and roots. So an exponent of a number or a variable says how many times you multiply it together. So 2 to the third power is 2 times 2 times 2. The root of a number x is another number which when multiplied by itself gives given number of times equals x. So the second root of 9 is 3. Well, why is that? Well, 3 times 3 is 9. So the second root would be 3, how many times it takes to multiply that number together. The second root is also called the square root. The third root, also known as the cube root of 8, would be 2. Why? Because 2 times 2 times 2 equals 8. We can also express roots and exponents as fractions. So the square root of 2 is 2 to the 1/2. The cube root of 2 is 2 to the 1/3. The fourth root of 2 to the third power, right? This is 2 raised to the 3 divided by 4. Right? So I have 3/4 in the exponent. Here are your laws of exponents. I would recommend you go back and look at this page. It tells you a lot about, well, what do you do when I have two numbers that have exponents I'm multiplying together? X squared times x to the third is x to the 2 plus 3 or x to the 5th. Right? Go through and look at these. These are your laws of exponents. We already talked about PEMDAS and how you solve literal equations. Remember, when you're evaluating an expression, you start with the numbers in parentheses and find those, then your exponents, multiplication, you work your way down PEMDAS. When you're solving literal equations, you're working backwards. You start by undoing the substitution and the addition, then you undo the multiplication, division, etc. So please go back and read this. All right, thank you. If you have any questions,